Hi children, we are again to discuss regarding the life science, and you know in lecture 3 that I have discussed in the class was on this chapter, physiological processes of life, but it was actually on the photosynthesis, light phase and dark phase. We have explained light phase and dark phase, and then today we are going to start with the mineral nutrition. In mineral nutrition, you know the plants are also in need of the minerals, and they intake along with the water the minerals also. That has been explained previously. How do they intake the minerals? Alright, now you see the mineral nutrition. In introduction we have come to know that they need minerals, and there are two types of minerals are there. For example, the macro elements, and number B, the micro elements. So what did I say? Two types of mineral elements are required: macro elements and micro elements. Macro elements are those mineral elements which are required by the plant in more amount, while the micro elements are those which are the plants take in a very small amount. And let us see what the macro element composed of. So we have the macro element where we get carbon, hydrogen, oxygen, phosphorus, potassium, nitrogen. We have sulfur, calcium and magnesium. Except of this, out of these 9 elements, some are non-mineral elements. Here you see the non-mineral elements. Those are out of the 9, 4 are non-mineral elements, and these 4 elements, non-mineral mineral elements, are there out of the 9. Well, we have the micro elements are there. The micro elements consist of boron, number 2 molybdenum, number 3 chlorine, number 4 copper, number 5 iron, number 6 manganese, number 7 zinc, etc. Cobalt and silicon are there, and they are just in trace. That means very less amount they are having in this element, mineral element nutrition. Well, we will just start to explain the function of those macro elements. Let us see first macro element, which is carbon. The carbon constitutes food, constitutes cell wall, cell membrane, DNA, enzymes, etc. Obviously, there are biochemical reactions are there. The carbon takes part in this as the macro element and does it. Second one is hydrogen, takes part in the chemical combination with carbon, because you know in photosynthesis carbohydrate is made. So carbohydrate requires carbon, hydrogen and also oxygen, that's coming later on. Oxygen, it takes part in chemical combination and along with the carbon and hydrogen. Except that, different kinds of oxidation in ETS is done by carbon, oxygen. And we have next is phosphorus, found in meristematic region of the plant. You know there are the meristematic region, intercalary meristematic region, or the tips of the plants. That is also meristematic region. There you find this, because they help change the growth of the fruits, and they also help in to constitute the ATP. That means the adenosine triphosphate, which you know as the energy coil. They also produce the NADP protein, and they help in protein synthesis, photosynthesis and respiration. They help in photosynthesis as well as in respiration. And then the cell membranes are made by them by phospholipids. They form phospholipids. So that is used in the cell membrane formation. Well, we come to the next macro element, which is known as potassium. The potassium, activation of the more than 40 enzymes is done. Then we have the DNA polymerization. That is also done by the potassium. Next we have nitrogen. It's the component of amino acid, and you know that amino acids that make the proteins. So they are the components of making the amino acids, and nitrogen base and the nucleic acids, and as well as the chlorophyll, that they make the chlorophyll also. Well, plant hormone and phytohormone is also helped by the nitrogen to produce. Then vitamins and coenzymes are also made by the nitrogen, the macro element. We have now the sulfur. Sulfur also constitutes the amino acids, that's like cysteine, methionine, and vitamins like biotin and thiamine is also produced by sulfur. So this is how sulfur also produces some coenzymes, and it forms the disulfide linkage. The sulfur forms the disulfide linkage, stabilizes the protein structure, and it makes poisonous substances by sulfide hydride, that is bond SHs there of group. And then we have the calcium, major constituents of the cell wall by calcium pectate. It is calcium pectate is one kind of insoluble starch. Alright, now we come to the next, that the calcium helps in protein synthesis and also converts the toxic oxalic acid to calcium oxalate, which is non-toxic. Well, magnesium is another constituent, the constituent of chlorophyll, because in the chlorophyll the green pigment is most important for the plants, and magnesium is the most important one, because magnesium with the component or the compound which is made by magnesium is known as magnesium chelate. That has the power of seizing the sunlight or converting the sunlight into heat, and which allows the water to break. That means by means of the photolysis. And by photolysis the water is being broken into hydrogen ion and hydroxyl ion. So this is how they promote the macro elements promote the things. And except for that, the activation of the various enzymes is done by the magnesium. It helps also in protein synthesis, and then it also helps in the carbohydrate metabolism. And it binds the subunits of ribosome. And you know the ribosome is present in the cell, especially it is found surrounds the endoplasmic reticulum, and also it is scattered in the cell where it is helping the synthesis of protein. Well children, now we have the functions of the microelements. Now you see, the microelements, first we have the boron, helps in the absorption of and the translocation of carbohydrates. It also helps in formation of calcium pectate and the pollen tube in the plants. Now we have come to the next microelement, is molybdenum. It helps in fixation and assimilation of nitrogen, because you know nitrogen fixation is a very, very important part in the plants. And then it helps in active nitrate reductase enzyme. And it comes to chlorine. Chlorine stimulates the enzymes of photosynthesis and helps in photosynthesis as well. Next is, we have the copper. So copper, constituent of the ascorbic acid. You know that ascorbic acid is nothing but the element of a vitamin, etc. And we have the iron. Iron, the structural component of thyroxine, flavoprotein, etc. And it helps in the chlorophyll synthesis as well. Well, we have the manganese. Manganese activates various enzymes gives protection against the damage caused by the light. So you don't always think that the light is only used for the photosynthesis and it is very nice for the plant. Sometimes due to the scorching light or various light activity, plants gets damaged. Now what happens, the manganese that helps and gives the protection against the damage caused by the light. Now we have the zinc. Biosynthesis of the enzyme trypsin is done by the zinc. So trypsin enzyme is synthesis by zinc. And we have the cobalt. Cobalt activate peptidase, and it also helps in making vitamin B12, increases in the capacity of the nitrogen fixation of the plant. And then the macro element silicon, cell wall in diatoms, a very minor kind of, a separate kind of algae-like structure diatom. Their cell wall is made by this silicon and provide the strength to leaves of gramine. Gramine is a special family. It is known as the family of the grasses. That means the paddy, wheat, all those are grass family. So in grass family, it provides the protection of the leaves because the leaves are very delicate, and so they give provide the strength. So children, these are all the elements which are required for a plant to survive. Well children, up till this you have gone through the photosynthesis and mineral nutrition. We have discussed the photosynthesis light path, that means the light reactions, and the dark reactions, the various pathways. Then we have discussed the mineral nutrition. And after mineral nutrition, we are going to discuss about the transpiration. So, the transpiration in plants is a very important process. In transpiration, what happens, the plants take water right from the morning till the till the next morning. So they go on absorbing water and water continuously because the roots never stop. Then what happens to all those water? You might say there is photosynthesis. Yes, obviously there is photosynthesis there. Obviously there is photosynthesis. But by the photosynthesis, the water is used up till the time then the sun is there. Up till the sun set, the photosynthesis goes on. After, as there is no sun, the photosynthesis stops. Then what happens to the water? So if the continuous sucking of the water is going on, that will go and that will create a lot of, loads in the leaves. And it might quite so happen the leaves droop, that they may fall. Then the nature is the greatest scientist. So it has its own magic, and this magic is the transpiration. We know the leaves have three very important functions. One is the preparation of food that you have already come to know through the lectures. And here you find the second one is the transpiration. Here we are explaining the excess water in the plants is released into the atmosphere to give the plant the stable state where they can go for the other job. Well, the third function is obviously the respiration, which we will discuss later on. Right now, concentrate on the transpiration. So transpiration is the process of removal of excess water which is not required by the plants. Now you see that this is the definition of site, means where do we find the transpiration? So we find the transpiration in these parts, that is the leaf, number one, and then we have through the leaves it goes on. Now site of transpiration. What is the site of transpiration or types of transpiration? I mean to say the cuticular transpiration. Second one is lenticellular or lenticular transpiration. Now third one is stomatal transpiration. Now cuticular, you see the leaf, and the leaf, on the upper surface of the leaf, it is a waxy coating. And sides, the leaf blades are also having waxy coating. Through that, the transpiration occurs, which is known as cuticular transpiration. And it is not a very much percentage. Now we'll come to lenticular transpiration. Lenticular transpiration is found on the stem. There are lenticels on the stem of the plants, and the plants do remove the excess water through the lenticular process, which we will find also in the fruit valves, and through that it is gone out. So this is also known as lenticular transpiration, and lenticular transpiration occurs when it is required. Now we have the main part of the types of the transpiration, which is known as the stomatal transpiration, and it is 80 to 90% of the total transpiration is the stomatal transpiration. 80 to 90%. Here you see the distribution of the stomatal transpiration. Now what is stomata? You see, if you have a leaf in your hand, plain leaf, anything, mango leaf, jackfruit leaf. So that leaf you take and see, upper part is waxy. That is the cuticular part. It is known as the upper part or the ventral part. And the ventral part is completely covered by waxy coating. And if you put it in front of your eyes and look at the sun, on the reverse side, which is in science known as dorsal side, you will find that there are many small dots are there. The dots are nothing but the holes. These holes are nothing but the openings, and these openings are known as the stoma singular and stomata in plural. So through this stoma and the stomata, the transpiration takes place, and that is the main type of transpiration, which actually includes 80 to 90%. Now again I say, you will find the stomata on the leaves, any kind of leaf, young leaf, old leaf, all kinds of leaf. Obviously not decayed leaves. On young stems, because you know, in the desert plants, the leaf surface reduces. So there the stems become flat, and the flat stem is green in color, and they perform the food preparation. So there is photosynthesis there, and also as that part, the stomata is present there, so their transpiration is also up. So we have young stems, and then floral parts of the plant. Floral parts of the plant, floral means where the fruits and the flowers and fruits are there, that part of there. And there is stomata present on the fruit walls also there. The young fruit walls having stomata is there. We have the fruit walls of the angiosperm. You know the fruits are of two types. One is angiospermic fruit and there is gymnospermic fruit. You see, some plants are having naked seeds like cycas. You go to Shevak region and the Shevak hills, you will find the cycas, and also up top on the hills you get the pines. The cones are there, the seeds are exposed, the seeds are naked, that means the seeds are open. So that is gymnosperm. What are they known as? Gymnosperm. Why we have the angiospermic fruit walls? Now what is angiosperm? Where the seed is enclosed in the fruit. Very good example, and the common example, and the lovely example, the very tasty example is the mango. Oh, so you children, you see, you go to the market or you have some small mango trees at your home, sometimes you pluck it and you munch. So this is, you see, you eat the fruit, but the seed is inside it. When you open the fruit, you cannot, or from the outside, you cannot see the seeds. When you open it, then you can find the seeds. After eating it, you can find the seeds. So they are angiospermic plants. The seeds are enclosed in the fruit. Now we have the stomata, which is not present in the submerged hydrophytes. Hydrophyte means the plants which live inside the water. So there the stomata is not in the dorsal side. Sometimes or most of the times the stomata is on the upper side. Well, we have the stomata is found in leaves of the pteridophytes also. Pteridophytes and also the mosses. Pteridophytes and mosses are also having the stomata. Now see, open and close the stomata. There are various factors for that. If the very much water is lodged, automatically there are in cell the exosmosis starts, and for that the stomata opens and releases the water. But it cannot just open one time and be closed for the whole time. So there is another process in the plant which is there, which is known as the potassium infiltration. By that theory, the stomata is opening and closing when is it required, so that there is no problem for the plants to undergo the transpiration. Now we have some factors on which the transpiration rate is dependent on. First factor is the external factor and the second factor is the internal factor. Let's quickly explain this two factors, how the transpiration rate is dependent on it. Well children, we have come to know about the transpiration. Now we will see the internal factors, external and internal factors by which the transpiration is actually required. That means they are dependent on the factors. Well, for the external factors you have humidity. When the humidity is more, the transpiration is more. Now second is the wind. When wind is more, the transpiration is more. Third is the light. When light is more, even the transpiration is more. The temperature is high, the transpiration will be more. Now we're coming to the next one, is the atmospheric pressure. If the atmospheric pressure is high, transpiration will be less. And if the atmospheric pressure is low, the transpiration rate will be high. And we have the carbon dioxide concentration. If the carbon dioxide concentration is more, then the rate of transpiration will be less. Well, we'll come for the soil conditions. The absorption of the soil, if the water absorbed is more, the transpiration will also be more. Now, internal factors. The leaf surface. If the surface of the leaf is big, then transpiration rate will be more. In desert plants, the surface is less. So, in cactus, surface is less. So, the rate of transpiration is less. While we come to the second one, the density of the root. That means if the root goes very, very deep and supplies more and more water, the rate of transpiration will be more because they have to keep the balance of the water. Well, the next one is the phytohormones. Due to the cytokinin, abscisic acid and potassium ions, the rate of transpiration varies. Well, we come to the enzymes. The enzymes promoting the photosynthesis will increase the rate of the transpiration, but enzymes helping respiration will reduce the transpiration. And well, we have all these factors are very much required for the rate of the transpiration. Now we come to the significance. That means what is the benefit through the transpiration is there. Well, we have absorption of water that is done by transpiration. If transpiration was not there, the plants would have stopped the absorption of the water. Number two, the elimination of the excess H2O, that means the water is required. Because if there is more water in the plant, then no absorption, no transpiration will happen. Number three, the cooling effect. The transpiration gives cooling effect in the atmosphere, so we can feel a little bit of soothing condition. Well, we have the upward conduction of the mineral ions. If the upward conduction of the mineral ions are more, so it's need to be having the more transpiration. Well, we have the distribution of the water in the plant body that has been done. If the transpiration is not adequate, what will happen? The distribution of the water will stop, so it is very much required for that. And we'll come to the last point, the transpiration maintains the turgidity. What is turgidity? The root pressure system down beneath the soil. What's happening is that if transpiration is more, then automatically root pressure will increase and they'll send the water to the upper part of the plant and transpiration will go. This is all about the transpiration and I hope you have gone through, and you will go through it very, very clearly. And for the question answers and all those, if the notes are given, that you will follow. And here, I think this is all for this. The following processes, the live processes, will be discussed in the next lecture. Thank you, and have a good day.